This video is sponsored by codingskill.net. Please visit our sponsor. Let's work through the base conversion problem. This problem is about binary representation of a non-negative integer. Given a non-negative integer n in base 10, we need to return a new integer that contains the binary representation of n. It will be a sequence of base 2 digits. The output will also be a number in base 10, but its digit will be 0 or 1. What is the size of the problem? Size of the problem is the number of bits in the binary representation of n. What is the base case? The smallest instances of the problem is the base case. In this case, the numbers that contain a single bit, which are 0 and 1. So the base case occurs when n is less than 2, where the output is simply n. What is the recursive case? We decide how to reduce the size of the problem. In this step, the simplest way is to decrement the number of bits by a single unit. This is accomplished by integer division of n by 2. This shifts bits one place to the right, so least significant bit is discarded. Let's now look at the concrete instance analysis. We will consider the case n is even. The input is 18. The result is represented like this in binary. In the reduction step, we divide the number by 2 and we get 9. The solution to this smaller subproblem is this. In the combined step, what do we need to do to get the final result? We need to multiply the output of the subproblem by 10. So for instance, if we are given this function of 18, it's nothing but 10,010. It's expressed in base 10. Let's now consider the second case when n is odd. The input is 19 in this case, and the result is this in binary. In the reduction step, we divide this number by 2 and we get 9. The result for this subproblem is this. In the combined step, how do we get the final result from the result of the subproblem? We need to multiply it by 10. That will give us 10,010. And we need to add 1 to get 10,011. So this function is the recursive function that operates on the given input. And this 10 goes here. And this function is operating on the smaller input for the subproblem. And we need to add the remainder of the number that's given to us. So what is the mathematical function? The mathematical function can be written like this. So we can now look at the code. Decimal to binary method takes one parameter. This is the number that is in base 10. The base case checks if n is less than 2. If so, we return n. Otherwise, we return 10 times the recursive call that reduces the input parameter by half, and then we add the remainder of the given number. Since it's base 2, we need to use 2 to calculate the remainder. So the binary representation of 142 in this case in base 10 is equivalent to this representation of that number in base 2. So you can calculate by adding these numbers for those ones in that position to compute the total as 142. Sign up for your free coding interview coaching call. Sign up for your free coaching call by going to codinginterview.coach.